Welcome to physics class. This is the battery with its future black atom, and we also have electromotive force. Electromotive force is actually the battery but without supplying the power to the circuit. So that's the thing. So electromotive force is higher in energy than the battery itself. And the negligible resistance, so the resistance inside the battery that is ignored at the moment to solve this problem. And then we have 4 resistors, so that's resistor 1, 2, 3 and 4. So that's the 4 resistors that we have. And then high resistance voltage, so that voltage does not allow current to pass through. And then 2 switches, 1 and 2, and then 2 ammeters, 1 and 2. Always check your stock before you solve circuit problem. And then switch 1 and 2, they are closed, and A is 1.2 ampere. So the unit, that's the current going to that direction. Okay, and then we require to have the reading on the voltmeter. So we only have 1 voltmeter, so that's the voltage at 3 resistance ohm. So voltage at, so you must specify where the voltage is. So it's voltage at 3 resistance, and then it's equivalent to the voltage at the other side, which is parallel to it. Parallel at 2 plus 5, so that means that they are parallel. So because they're parallel, the voltage is the same. So you find that voltage voltage equals to IR, and then we have 1.2, and then the total resistor is 7, so we need to find the voltage there. And then 1.2 times 7 is 8.4 voltage. So that's voltage at 3 resistance, 3 ohm. And now what happens there, the current goes through that side, so 1.2 amp, and then we have current at 2 is 1.2 amp plus. We need to find the current passing there. So current at 3 ohm, what is it going to be? So using the voltage again, Ohm's law, I is equals to IR, and then you have your current there is your I there is current is voltage over resistance. So your I there is 8.4, and then your voltage is 8.4 and the resistance is 3, and then 8.4 divided by 3, punching that in your calculator gives you 2.8 ampere. So that's the current that is passing through on the 3 ohm resistor. So we should make sense, because if you have 7 going for 1.2, then 3 you expect it to be a bit higher because the resistance is low, and that's 2.8. So now to find the total current that passes through ammeter A2, so ammeter 2, that would be 1.2 plus 2.8. so all of that gives us watt. So we add them together, we find that 1.2 ampere plus 2.8 ampere gives us altogether 4.0 ampere. So that's it. So that's our answer for 2.2.2. Next, we are required to calculate power. So power is the product of the current and the voltage. So voltage there is 8.4, so we got a voltage there at 8.4, and then we have current at 4.0, so 8.4 and current is, that's that, not that one. I think our current is that one, 2.8. So our current is 2.8 at the resistor, at the 3 ohm resistance. And then we have power, which is I current multiplied by voltage, so which means our current 8.4, just it's the same thing. So it's 8.4 multiplied by 2.8. Our current there is 2.8, voltage is 8.4, so that gives us 2352. 2352 answer. So thank you so much for watching. Don't forget to subscribe or follow.